Hi everyone. Today let's talk about section 3.3, the products and quotient rule. Big idea. To calculate the derivative of a function that is formed by combining two other functions using multiplication or division, we use the products and or quotient rule. Big skills. You should be able to calculate the derivative of a function that is formed by combining two other functions using either multiplication or division. So here we have the product rule. If f and g are differentiable, then the derivative of the product equals the derivative of the first guy times the second guy plus the first guy times the derivative of the second guy. Okay, so how do we prove the product rule? So I'm going to prove it here. So the derivative of the product equals limits h is 0, h goes to 0, f of x plus h, g of x plus h minus f of x, g of x all over h. Okay, so I'm going to change something. Okay, so what I'm gonna do is I'm gonna subtract something and add that thing back. Okay, so what do I want to subtract? So I want to subtract f of x and g of x plus h. Okay, and then I want to add this guy back. So I want to add f of x, g of x plus h. Okay, and then I still have the f of x and g of x right here. Oh, I ran out of space. Okay, never mind. So now I'm gonna group the first two terms together and the last two terms together, and let's see what happened. So the first two terms, do you see the common factor g of x plus h? So I can group it together. Then I have f of x plus h minus f of x over h times g of x plus h, right? We factor out g of x plus h. And then for the second one, I have f of x is the common factor, so we can factor that out. Then we have g of x plus h minus g of x over h. So now when we let h goes to 0, well, this guy is actually f prime of x. And when we let h go to 0, this guy is g of x. And this guy is f of x. Well, this guy is g prime of x. So that's why we get the product rule formula. Well, that is f prime times g plus f times g prime. So the derivative of the first guy times second guy plus first guy times the derivative of the second guy. So I hope that you can memorize this formula. So by the way, for Calculus 1, all of our exams, there's no formula sheets. So all the formulas that you see in our course, you need to memorize it. Okay, so that is the rule that I agree with Professor Heaven, okay, and the math department or the calculus course, you won't be provided formula sheets. Okay, so because then you can understand the formula, you're gonna use it a lot. So that's why I really hope that you can memorize all the formula. Okay, so that is the product rule. Well, how about the quotient rule? The quotient rule is it's very similar to the product rule. You can see the numerator is gonna be almost the same, except the middle guy, instead of plus, we have minus here. And the denominator is the original denominator squared. Okay, so that's the first guy. We should say top guy or bottom guy. So it should be the top guy prime times bottom guy minus top guy times bottom guy prime, right? Over the bottom guy square. That is the quotient rule. Okay, so we're not gonna prove the quotient rule here because it's more complicated and take more time. But if you're interested, please read your textbook or come to see me. I'm very happy to go for it with you. And last time we talked about the derivative of e to the x is just e to the x. Today, what happens if we have a k in the exponents? Well, the derivative of e to the kx is k times e to the kx. Be careful! Many students make this mistake. They confused with the power rule. Oh, they think the power rule, oh, this guy is n x to the n minus 1. So, oh, e to the kx. Oh, I put down the k and then e to the kx minus 1. No. Don't subtract 1 from the exponent. Okay? I make a story here. So, I say, father looks like the son. And the father has the mustache. Okay? So K is like the mustache. So father and the son still look the same. So you still have e to the kx. Okay? So this is the son. This is the father. Okay? But the father has the mustache. K is like the mustache. Okay? But father and son, they look alike. Okay? So you still have e to the kx. Don't change the exponent of that. Okay? Alright, so let's continue. Find the derivative of the following function. First of all, make sure they are of the standard form. So we have 4 roots of x. Well, that is x to the 1/4, right? E to the 2x. Well, this is a product. So we use product rule. So I hope when you take the derivative, do it slowly, step by step. Each step only use one rule, okay? Only do one thing. So here we see products. So let's do product rule. What is product rule? That is the first guy, prime. Don't differentiate at the same step. It's very easy to make mistakes. Okay, so let's just write on the product rule. The first guy prime times second guy plus first guy times second guy prime. See, I just write on the product rule. I'm not differentiating the factors in the same time. And I do it in the next step. Okay, the next step for the factors with no prime, just copy them. For the factors with the prime, we're going to differentiate them. So x to the 1/4 derivative is 1/4. X to the 1/4 minus 1 is negative 3/4. And e to the 2x stay there. X to the 1/4 stay there. E to the 2x derivative is 2 e to the 2x. That's the derivative of the product. So far, so good, everybody. You can see each step we only do one thing. All right, let's continue. Okay, part B. Are all the terms in the standard form? No, not this one. Okay, so let's change it into the standard form. 2x cubed minus 4. Well, what is this? What is x times square root of x? Square root of x is like x to the 1/2. X to the 1/2 times x is x to the 3/2, right? And then 3x squared plus 11. So we have quotient. Let's use quotient rule. Okay, but when you use quotient rule, write on the quotient rule, okay? So what is that? Well, the denominator is the original denominator square. And then the numerator becomes the top guy prime, the top guy prime times bottom guy minus. Okay, when we do product rule, we have add, but when we do quotient rule, we have minus, okay? And don't forget the parentheses. Your baby parentheses is so important. Okay, so minus the top guy, don't forget your parentheses, times the bottom guy prime. See, the first step, I just write down the quotient rule. The next step, whenever you see the factor with prime, you're going to differentiate. So, and don't forget your parentheses. The derivative of 2x cubed is 3 times 2, 6x squared. The derivative of 4x to the 3 half is 4 times 3 half. X to the 3 half minus 1, 1 half. Okay, so we continue. The derivative of 3x squared, well, that is 6x, right? And then derivative of 11 is 0, okay? So, and then 3x squared plus 11 squared. So far, so good, everybody? Oh, and you can see, probably you can simplify a little bit. You can see this guy. This guy is actually 6, right? 4 and 2 cancel. You can 2 times 3 is 6. And you don't need to multiply all the terms out. You can just leave it like that. Okay, everybody? So you don't need to simplify it. Okay, the only case you might need to simplify is when you are looking for higher order derivative. So you want to have the simplified version before you continue and differentiate one more time. Okay, but right now we're only asking to find the first derivative, and then as long as no factor has the prime, then you can stop here. So far, so good, everybody? Alright, let's continue. Okay, so let's look at this function. Well, we see product and quotient. So when you take the derivative, you always look at from the format from the outside to the inside. Well, the outside format is something times something. So the first step to use, so step 1, use product rule. Okay, something times something. So product rule is derivative of the first guy times second guy plus first guy times the derivative of the second guy. See, we write down the product rule. Okay, next, which factor has the prime? Let's continue. Oh, this guy has the prime, but it's a quotient, so we use quotient rule. You see, each step we only do one thing. I really hope that you can do it step by step. Sometimes I know some of you might be very smart and you want to write it down, but you're smart, but it's also very easy to make mistake. I personally sometimes make mistake. Okay, so I really hope that you can write out the steps in the exam. If you write more steps, if you make a mistakes, because if I can see your you get partial credits if you write down the steps. But if you don't write down the steps and you have a mistake, well, your answer looks like to me is just the wrong answer. Then you don't get much points. But if you show me your steps, I know, oh, okay. So you understand the steps and you only make some algebra error in one step. So I only subtract 2 points from one step instead of the whole thing. Okay, so please write down more steps to get partial credit. Okay, quotient rule is the denominator, we square it, and then the top guy prime times bottom guy minus the top guy times the bottom guy prime. So this whole thing is only this guy, the first factor, okay? And then we still have 7x to the minus 5 plus e to the 6x. And then we have 3x plus 2 over x cubed minus 5. And the derivative, is 7 times -5, -35. -5 minus 1, -6. And 6e to the 6x. Don't subtract 1. Remember, father looks like the son, but the father just has the mustache in front of it. Okay? Alright, are we done? Not yet. We still have some factors as the prime. So let's continue. 3x derivative is 3. The x to cube derivative is 3x squared. 5 derivative is just 0, okay? So x cubed minus 5 squared. And then we have 7x minus 5 plus e to the 6x. 3x plus 2. X cubed minus 5. -35 x to -6 plus 6 e to the 6x. And you can now see all the factors, we don't have prime anymore, then you can stop here. You do not need to multiply them out or simplify. So far so good, everybody. Let's continue. So example 2, we want to find the tangent line of this function at the point 3, 2. Okay, so let's see. First step, we want to compute the derivative, right? Well, the derivative, this is a quotient, so we use quotient rule. Well, that's the denominator square. Then we have the top guy prime times bottom guy minus top guy times bottom guy prime. Okay, top guy prime, derivative of x squared is 2x, derivative of 1, 0. Minus x squared plus 1. Derivative of x squared is 2x. And derivative of 4 is 0. Okay, so here, because we are looking for the slope, so it's better to simplify it. If I only ask you to find the derivative, you can stop here, but we need to find the slope. So it's better to simplify it. Can you see we have a common factor 2x on top? Let's factor that out. And then we have minus x squared plus 1. Don't forget the parentheses, everybody. So now let's distribute. So we have minus x squared and then minus 1. Okay. And then x squared minus 4 squared. Wow, can you see something amazing? Cancel, they cancel. -4 minus 1 is -5. So we have -5 times 2, -10x all over x squared minus 4 squared. Okay, then we want to find the tangent line. So we want to find m tangent. Well, that is, we plug in x's. What is x? Is it x3 or is it x2? We plug in the x is 3, and then the y is the f of x is 2, right? Okay. So f prime of 3. So minus 10 times 3. Well, 3 squared, 9 minus 4, 5, right? 5 squared downstairs. Oh, you can see square, we cancel, we get 2 left. We have minus 6 over 5. That is our slope of the tangent line, right? Then what is the tangent line equation? Y minus the y coordinates. Well, here the y coordinate is 2, but if the y coordinate is not given, then you need to plug the 3 into our function f to find f of 3. That's the y coordinate of the point. So that equals the slope, -6 over 5, x minus the x coordinates, which is 3. Alright, so we have y minus 2 equals, distributes, -6 over 5x plus 6 times 3, 18 over 5. And then y equals, so y equals -6 over 5x. When we add 2 on both sides. Okay, when we add 2, we get 28/5. So this is the tangent line. Okay, so questions. If I ask you to find the normal line, what do you do? So if I want to ask you to find the normal line, well, M normal is, what is M normal? Negative reciprocal, so it was negative, now become positive. 5/6. Okay, then your normal line is y minus, the point is the same, but just the slope replaced by 5/6. Okay, and you replace it in this point slope form, not the slope intercept form. Don't just replace this by 5/6 and with the y-intercept the same. No, the y-intercepts are different. Okay, and let's distribute. So we have 5/6x minus 6 and 5 cancel. We have, 6 and 3 cancel. We have 5/2. So we add 2 on both sides. Then 2 minus 5/2 is minus 1/2. So this is the normal line. All right, everybody. So this is the normal line. Okay. And this is the session 3.3. We learned about products rule and quotient rule. Okay. So remember, when you solve those into derivatives, look at the formulas of the functions from the outside to the inside. And each step, make sure you only do one thing. Don't skip steps, okay? So write out more steps. It can reduce the possibilities of making errors, and you can get partial credits if you make some mistakes even, okay? All right, have a nice day. Bye.